Fire Service Data and Tech Talk.
Hey, everybody, it's Eddie Buchanan with the Fire Service Data and Tech Talk podcast on fire engineering, the September 2025 issue. We're getting into fall. And, the last couple of months, we've been talking a lot about technology, the data and tech talk. So we've had a little bit of a run of technology lately. So I thought, man, let's go digging deep on some data, right? So I think when you look at what's out there in the world and in data analysis and that type of work, it seems like the real big lift, like the high level of that kind of world, is really real-time deployment optimization. It's one thing to look backwards through your data and see trends historically. It's another thing to look at things even in real time. It's another thing to predict what might happen next, and to go even further to understand what to do about it, right? So there's these layers of leveraging your data to do some really cool things. So I've got some really cool guests with me this month to talk about that with real life experience. These are folks that deal with it every day and have had some really good success with it. So I want to welcome to the show Jamie Timm. Jamie, welcome. Thanks for coming on. You want to tell everybody a little bit about your background? And like I said, nobody knows more about this than you, I don't think, on the planet. It seems to me.
Yeah. Thanks for inviting me on today. I'm excited to have this conversation with you guys. I have been working in the public safety software space for almost 15 years now. And, like you guys, we've seen the fire service change a lot. We've seen the technology capabilities change a lot. And it's interesting because not everything is always improving in a linear way, right? We do a lot in the fire space and on the EMS side to sometimes react to what's happening. And sometimes we're hoping that technology kind of leads the way. So I think it'll be great to get into some details here about where we see actual departments that we work with managing to get ahead of these things and find the best technology to help them solve these problems in real time.
Awesome. Thank you for coming on. And Jason, Captain Jason Heartisan, Jason from Prescott, tell us about yourself, man, and thanks for coming on the show.
Yes, sir. Thank you so much for having me. It's an honor. I'm a captain with Prescott Fire Department. I've been in Arizona working in the fire service for 15 years. And I got onboarded working with the project to optimize our response times in our area. And we've utilized some move up module programs, and so that's probably why I'm sitting here with you guys today. So I've become the subject matter expert for my department for that.
Awesome, thank you. Let's start with the beginning. So the title of this episode is Real Time Deployment Optimization. So I'd be curious to see, like, Jamie, tell us, what does that mean? If somebody's not familiar with the data world and what's possible out there these days, give us like the kind of executive summary of what we mean by that topic.
Yeah, and I think it's great that when we started, you distinguished a little bit between what's real time and what are we doing in terms of planning, because planning's great. It's very important to look ahead and do the best you can to try to meet what the future needs. But at the end of the day, public safety is real time. Things are happening minute by minute, changing constantly. And being able to utilize whatever resources you currently have available, whatever your best laid plans have been prior to that, means that you're always able to leverage your resources in the most efficient way. You might have had funding for 15 ambulances in your city, but 5 people called out sick. You're not going to run at full staffing today. What do I do with the 10 ambulances that I have? Where am I able to put them? And being able to leverage move up technology means that we're using, some recognition of historical patterns of incident activity. We're looking at what types of calls they're going to, how long they're waiting at hospitals, how long it's taking them to traverse different parts of your city at different times of day, and making the best decision to make sure that when that next emergency does happen, you did the best you could to have the right resources in place. And, I'm sure Captain Jason will tell us here too, it's not a crystal ball. It's not perfect. You can't always have everything exactly where you want it to be. But knowing that you did the best with what you had is, I think, key in some of this public safety context.
So what are the ingredients in this cake? Like if I was gonna look at leveraging some sort of technology in this, just in the zip code of this? What things do I need to have access to? What kind of data? How complicated is it to begin?
You can start very simple. You don't have to have everything in place before you kick off these types of technology projects. But the more data you have, the better. The cleaner your data is, the better. And this can be everything from incident and response data that was tracked in your 911 CAD system or in your RMS data system. We want to be able to leverage the best possible street network. All of your GIS technology really comes into play. It's hard to, do an appropriate travel time estimate if your street network is 15 years old and doesn't actually reflect the connectivity that you have now. And really being able to have the right integration with your real-time CAD system, right? So LiveMom is very dependent, and a lot of technology that we use these days, not just our software, but these applications are very dependent on CAD's ability to give us the right information at the right time. So there's some technological requirements, but even if you have no historical data because you just bought a new CAD system and you don't have anything, there's a lot of ways to fill in the gaps on that and to make educated guesses where necessary.
So we need data, we need GIS information, and we need CAD integration. Basically.
And maybe the most important is you need a Captain Jason. It is so key to have somebody from the department who is a subject matter expert. And you need to be able to bridge that gap between communication, technology, and operations. A lot of times we run into implementations where, maybe there was a dispatcher preference that they do move ups in a certain way and they only dynamically deploy resources when their supervisor told them this was appropriate. But in reality, you might get into a situation where the fire chief or the battalion chief who's actually at scene and looking at this knows that he wants movements done of apparatus in a certain way. And there are legitimate interests on all stakeholder group side. It's not that one group has all the answers, but you do need to have agreement amongst those stakeholders. And generally having a Captain Jason in place who can navigate that and speak up on behalf of all the groups to really kind of get the best settings in place really does help make the project a success. That's definitely key.
So, yeah, I guess, right, the decision of how you want to operate, that seems to be a challenge for a lot of fire departments, is to articulate, this is what we want to do, like to understand how we operate. And it's not, A shift's working today, so it's going to probably be this way. And then B shift is something else, right, to get that agreement. And I've seen it usually when it's one thing when they say, okay, this is what we want to do. That's great. When they say we have to have a few meetings, okay, that's cool. Yeah. When they say we have to vote, then I get scared.
Well, right? Voting is tough too, right? But also this idea that there's one person who they want the software to behave exactly like this one person likes to do things. That's very difficult because you look at this over a period of time and people change roles, and sometimes people's experience is based on what they learned coming up, but that doesn't really match the needs of the city 20 years later. And so it's that's also a challenge when you get kind of this idea that I only want to do it this one way and it has to match exactly. That's a real problem.
All right. Well, Jason, tell us the story, man. Tell us about Prescott, like where you came from, like where you guys started from, and then how you've evolved with the technology today.
Yeah, well, we got a new chief that came in 3 years ago, and from Colorado, Holger Dura, and he had known about move up technologies that had been utilized in Colorado. And one of the primary issues that he identified with our department is our response times. So, looking at the whole package of Prescott Fire Department, we have had the same amount of staffing and engines within our system since 1995. So you can imagine the population growth and call volume growth from 1995 to today has slowly been increasing over 30 years, and we've had the same staffing levels. So getting more engines on the road is a much bigger challenge than implementing something like a move up technology to reduce response times. So that was Chief Dura basically said, okay, this is a way we can utilize a technology to start ticking down our response times to where our goal is. So our average response times in 2023 were 11 minutes. And Chief Dura had set the timestamp goal of 6.5 minutes. So that's a huge gap. And move up technology is only one piece to how to get there, but that was kind of like a bang for our buck, the most cost effective and quickest way to actually start to tick those things off. So that was like one of the first things he recognized. So he threw it out to the department. Hey, is anyone interested in taking this on? And we had a move up system in place that had basically been established 20 years ago by some chiefs in the room. And they kind of had a map and they had a whiteboard on the wall. And they said, all right, well, if this engine and this engine go on a call, then we'll move this engine to there, kind of thing. And it was based on intuition and how they're looking at the system in general. And it was just kind of the feel of where engines should maybe hopefully be, kind of thing. And the parameters they set, I'll give you some numbers. In 2023, in our system, 2022, we ran, we have 10 engines in our system with our mutual aid partners, because they run out of the same dispatch center. 1,500 move ups in 2022, and out for 10 engines. So I don't know if you can kind of do the quick math on that. There were a couple engines that were kind of the taking the brunt of the move ups, but they were moving up 10 to 15 times in a day. And then we also looked at kind of the amount of times that they actually kicked a call while they were on a move up, which was less than 6% of the times that they were moving up. So amongst running calls in their own area. And so there were days when that engine was those couple engines that were move up heavy were putting on 300 to 400 miles in a 24-hour period. So another goal that we set when we started to adopt the move up technology is that's wear and tear on an engine. That's wear and tear on an engine. That's fuel cost. That's time allocation for those crews that they could be training, they could be eating, they could be doing all the things that need to be happening other than just moving up and uselessly kind of yo-yoing from one area to another and never actually kicking a call. If you think it's less than 6%. That's 1 out of 20 times that engine would actually move into another area. They kick a call. So 19 times they go to that area, they're cleared, and they drive back, and it's probably about an hour's worth of time out of that engine's day. And it was just it was unsustainable. So the reason I got involved is because I knew this was a very inefficient system, and I became very passionate about knowing that move ups was a waste of time, a waste of our time. So that was the first piece of it, but then also that we can ultimately do things like reduce response times for our community, right? And reduce wear and tear on our engines and all that kind of stuff. So personally, I had a vested interest because I'd just be really mad every time I was on a move up and we'd move back. I was like, well, I didn't sign up in the fire service for this kind of thing to just be driving 400 miles in an engine in 24 hours. I might as well just become a truck driver, So we as the program manager for the move up technology, it involved having a very intimate knowledge of our system, where engines move, how those types of things happen, and then engaging with our stakeholders. So, of course, dispatch is number one, but then it was also like IT. That was a huge piece to just engage them with the whole process. And then the line personnel too, because, they didn't trust it. It was like a hard thing to trust, as well as dispatch. You mentioned a little bit earlier, Jamie, when you implement something like a move up technology in the previous system, people have a hard time adopting and adjusting, right? So there was a lot of kind of education about implementing this technology, trusting it. So talking with all our stakeholders, as well as our mutual aid department, neighboring department, we had to talk with them a lot and work through all these things. So we, first couple of weeks we had it on board, we either had captains that wouldn't actually do the move ups that our technology was suggesting, or dispatchers that wouldn't do it. They'd say, "Oh, that doesn't make any sense." But what was cool is there's kind of a term called the batting average. So an engine moves up, is initiated the move up, and wheels start turning and they start moving up into an area. And then do they kick a call in that area or do they not? Right. And that's really like down to the nitty gritty, especially as a captain on an engine, when we're actually doing that, does it feel like a waste of time or not? Right. And is that batting average? So what was the percentage of times that an engine is moving up into an area and is actually being useful by kicking a call in that area? So over a couple of years, we kept tweaking some of the things in our thresholds and stuff, but I'll just give you. So in 2022, we ran 1,500 calls, and less than 6% was the batting average. And in the first year of using that move up technology, we ran 225 move ups total. So we reduced the actual move ups by, let's see, if I were to do the quick math on that, would be 90%, basically over 90% of actual move ups. And the calls caught while on move ups was increased to 57%. So our batting average went from 6% to 57%, and we reduced the amount of move ups by over 90%. So now when an engine actually is initiated into a move up, we all trust, well, there's a pretty damn good chance. There's a 2 out of 3 chance that we're actually going to be kicking a call in that area. Okay, this is efficiency right here. This is like utilizing the system right, and has reduced our response times in the system. Not down to 6.5 minutes, of course, but from 11 to I can't actually remember what our response time is for this calendar year, but we're below 11 minutes. So we're slowly ticking the way, making our way down there. So it's been amazing to have that type of effectiveness in the system and be a part of a program that has a cultural change as well as a effective change for our community and reducing all the wear and tear on our engines and time and all that stuff. It's been incredible.
So I'm curious about the batting average. What is good, right? Like, so you went certainly 6%, not so hot, right? But when you get up, that's a remarkable improvement to get up to 57% of the time catching a run. So better than likelihood you're going to catch a run. Jamie, from the data perspective, where is the sweet spot? Like, are you trying to be higher, 50, 40, 80? How does that work? What's the strategy there?
There's definitely a sweet spot range, because what you don't want to do is shoot for a batting average of 100%, where you move up and every time you catch a call. In the data, that would be indicative that you should have done move ups and didn't, right? So this is probably a case where you had an incident happen in some other area and you failed to do a move up, because it is still about balancing risk and risk management. We want the batting average probably to be anywhere from 50 to 70%, depending on whether it's fire apparatus or EMS apparatus. Ambulances, we want to shoot for a higher call catching rate there, a higher batting average. Part of the rationale with ambulance is that they, in most cities, tend to go from call to call to call. It's really rare that you've got ambulances that have a good amount of downtime and that they're not already putting tons of wear and tear on those vehicles. So it's really just about being strategic with where they're located. And you want a very high batting average for where you're moving them into. With fire apparatus, it is different. You want to be able to preserve their availability in their home area. That is key. There's a reason that they're in that location to begin with most of the time. There's sometimes you get cities that built a station somewhere and they can't even tell you why they put it there. But, most of the time, that's not the case. And so you really want to make sure that you're balancing this idea that there will be cases where you do a move up and you do not catch a call, but that was done in service to the idea that had there been a call, you would have been too far away. And it was a good time of day to do it. It had a high enough probability that it was worth it to go, even if you didn't end up having a run. And so we also want to make sure that the algorithm is doing all these balance checks that say, yes, there's a high probability in the area that I would be moving up to, but there's actually a higher probability in my own home area. And so I won't do a move up at all in those cases. And so had you done a move up, it's kind of a flip of a coin, whether you would have gone to the incident in the area you moved up in, or whether you would have just turned around and gone back to your own home area. So I would say that where Prescott is right now with that kind of batting average, that's solid. That's very good. You guys have really set your application up for success there.
Amazing. So how does it, tell me more about this predictive thing. Like, how does it, you mentioned an algorithm. It seems like it's thinking. I'll mention the 2-letter word here in a minute, but how does it think? Like, how does it know? How does it predict? What's it doing?
Listen, it's cooler than an AI chatbot, right? It's not It's not quite ChatGPT, probably right somewhere in the middle there. These types of algorithms are using the best practices in operations research science, where you've done all these studies into the types of mathematical modeling that, given a certain set of data inputs, you can make a really educated projection about future outcomes. And LiveMom and some of the technology that we've seen out in the public safety space have done a good job leveraging these types of techniques and using these data inputs about where units are located, what time of day it is, what type of job they're on, and how long they're going to be gone for, to help determine when you do have a geographic area in your city that doesn't have any resources nearby, whether or not there's a high likelihood that a new incident will happen there, because that can be very key. If there's a Sunday morning at 2 a.m. in a pretty remote part of your town, maybe it doesn't make sense to move another piece of apparatus there and wake a crew up and have them drive across town just to sit there in case. But if it's Friday night and there's a high likelihood that there's going to be an incident that happens here, it probably is worthwhile on balance from an operations perspective to go ahead and cover that location. The algorithms are constantly improving over time. And again, the more data you have, the more data we can leverage. When you've got data about special events, or you host different sporting events, or you have, big comedians who come into town, whatever it is, you can also have the software kind of account for those types of more situational events and make sure that we're using predictions and data projections that align with what's really happening today, not just an average of the past couple of years. And so there's a lot of flexibility in how the algorithms can be tuned to what's important to that city from an operations perspective, and make sure that it's not generic. It's custom to what you guys are looking for.
Well, that's what I was thinking. It sounds like it's really customizable. Like, so yeah, it comes in a box, but you can tune it to fit whatever the local needs are.
That's right. You might be a city where it doesn't matter what the risk is at that moment in time. You're always going to move up and cover this area because it's politically sensitive, or because it's just so remote, it's hard to reach. And even if the call likelihood in that location or that time of day is very, very low, the risk to public safety, to your community, If an incident happens and is large and escalates, it's perfectly reasonable to not use the projection software in that moment. And instead you just go ahead and move up and cover. It doesn't matter what the risk level is. You want to go ahead and do the move anyway, no matter what. So a lot of times we work with some cities that have some areas where they still have very tall buildings that are close together. And in some of those locations, they're going to be more aggressive about covering it because they know that even if a minor incident happens, the probability of it spreading is quite large. The difficulty in getting crew up to those kind of vertical responses is challenging. And so they want to have lots and lots of crews available nearby. And some of that's done in your CAD system with your response plans. But some of that is proactively doing move ups into an area, regardless of what the probability is too. So you've always got the next wave of of apparatus kind of moving closer and closer to that incident as well.
Good, Jason.
I wanted to speak to that too, just shortly. That's been interesting once we implemented that and we've gone farther and farther down the road with better data. It's not always intuitive to us what the software is suggesting, but it's almost always right. It will say, well, that's kind of a weird move up, and it'll send an engine that's maybe not the closest engine to that move up. And then that other engine that didn't move up, they kind of leapfrogged, kicked a call, and then the engine that is in that other area that moved up, they kicked a call, and it's like, wow, software was actually right. So it's kind of this really interesting. It has a lot of predictive data points that go way beyond I've talked to dispatch about it too. They say they feel the same way. They'll say there's no way we could have anticipated this move up being accurate, but it almost always is, which is really, so it's fascinating to see how deep the software can get into the data to know what the suggestions are. It's incredible. And it goes way beyond our capability to understand it, on a surface level. It's pretty cool.
Yeah, Chief Doerr was telling us about those stories, and those are the stories that make the software more accepted, I guess, right? Like when you have those success stories like that are nothing you'd ever guess to do, right?
Yeah, firefighters are competitive, and we want to try and be like beat all systems, and not trust technology. But when it beats us time and time again, and it beats our intuition, then it's like, that's when it really it affirms itself. It's pretty amazing.
Yeah.
I think it's funny when it gives a software recommendation that you're not expecting or you're not familiar with, because the whole reason that the application suggested that is in part because of the data and the projections, but it's also because that's the type of operational policy that was expressed to us from the stakeholder groups.
Yes.
And it's like this reflection back to our agencies that this is what it looks like to be in alignment with your operational strategy. And maybe you weren't as in line with an operational strategy prior to implementing the software, but it's different seeing it in real time. Oh, we did want to move an engine every time the closest four were unavailable on a long call for a long period of time. And the likelihood of a call happening is over 60%. We're going to go ahead and move. And you like the way that sounds on paper, but it's different seeing it in reality. And you're just like, yeah, we're going to have to trust it and see what it does.
Yes.
Amazing. I'll tell a story on I won't name names, but a lot of it has to do with discipline, right? Organizational discipline.
Yes.
And I was talking to a buddy of mine, a fairly large metro type department that was using such technology, but they had some issues where their companies weren't necessarily staying where they were supposed to in the district, right? So hypothetically, they might have gone for ice cream somewhere in the city. And as those units, started, across town stuff, not up the block. Like another battalion kind of stuff. Riding out to go meet, the technology did not know what to do with that, right? So imagine when these units start just for no reason or not where they're supposed to be, it's going to do what it does, which, and anyway, it didn't end well for everybody from an HR perspective. But interesting little nuances that it does require some level of operational discipline, right, to for these things to work. I just thought that was the funniest thing I ever heard when I heard it. But so Jason, downrange of this, right? Like you guys, how does this translate to the budget guy? Like, so obviously this technology costs money, but you guys, man, you saved a bunch of mileage, right? Like, were you able to translate that into some kind of dollar figure or anything?
That's interesting. I'll crunch the numbers on that and try and come up with some dollar amounts. I mean, it's hard to, I guess we could look at our heaviest move up engine that was in the system before the software and see how many miles it put on in a year. And then do the numbers on how many miles it put on in a software year, move up software year. And then it's hard to put a dollar amount on that because sometimes, we could go, 5,000 miles without any problems on an engine, and other times where it's in the shop every other day kind of thing. So hard to put a number on it, but, it's got to be significant. You know what I mean? Fuel costs. I could do a pretty straightforward fuel cost analysis just in fuel, which I know would be thousands of dollars for just one engine, let alone all the engines in the system. So, and yeah, on a budget side of things, it's like bang for your buck. It's like the most cost effective thing you could use to utilize to hit many benchmarks, like reducing response times as well as fuel costs and all those types of things. It's like the quickest, easiest way to start being a more efficient system and bang for your buck. So I'll put some numbers together. That'd be really interesting.
Yeah, I'd be curious to see
a number value to it, what we've saved on multiple layers. That sounds great.
And you mentioned a lot about, a lot of stakeholder involvement in this. Walk me through quickly, like just what was the implementation like? Like what kind of, was there training, or you just kind of like do overviews? Or how did you coach?
Yeah. So we went into a like beta period where we had the software analyzing our CAD data, and we had 5 years of CAD data that the software could work with. So that was great to that it could start, really utilizing that 5 years worth of data and response times and so on. And then we had to be looking at, what those responses were, what types of responses and all those types of things, and kind of making it all sync up from the CAD side to the software side to IT, all those types of things. So there was like a software integration orientation time that took a couple months of them crunching numbers. Then we had to, as a senior leadership in the department, come up with what the goals actually were with the program, which was reduce response times, minimize wear and tear on engines. Those were the two primary goals for the program. And then there were a couple kind of parameters that we had to establish within the software program to actually when it would trigger a move up. So there's some parameters like the likelihood of a call kicking out in an area. We could make that as low as we wanted or as high as we wanted, and that would then trigger a move up. So we had to kind of find the sweet spot with where we wanted that number to be. And that involved dispatch and chiefs basically to figure out that number. And then I did basically an in-service with all captains and primarily captains. I was I went around and actually had a face-to-face with every single captain in the department and told them what the program is, what it's going to look like, how it's going to look when we launch it, type of thing, to have the buy-in, the education, if a lot of things in the past, the Prescott Fire Department, we would implement some type of new system or program or something. And some people were in the dark about it and some people knew about it and stuff. And then there's a lot of griping if, when people are in the dark. So the education on the line, specifically the captains, was huge. And I would have conversations about them. They're asking questions about the whole process. And it was pretty cool that once we did go live with the program, everyone knew exactly what was going on. And I also did that with dispatchers too. So I sat and dispatched quite a bit and showed what the software was doing, how it looks, what it looks like when there's a coverage gap in an area, when it goes from green to yellow to red, and how that's gonna, so there was a lot of just sitting down with dispatchers and talking to them what it looks like, what happens when when a suggestion pops up, and what their process is in actually dispatching an engine for a move up. And then on the other side of that, it's what happens when things have resolved? When do we clear the move ups to have those engines return? That was kind of another, once we had launched it, it was we hadn't really anticipated, the software doesn't actually make a suggestion on when a move up is no longer needed. It'll show that the coverage gaps are covered, but it doesn't actually come up with a bing for the dispatcher to say, oh, now the engine can return. So we had to set those parameters and types of things. So it was a success when we launched it, because I spent a lot of time with all the stakeholders, just educating and talking and having discussions and stuff. And so when we did launch, it was very, very quickly adopted. I think the hardest stakeholders to actually adopt the system were the dispatchers. They were the ones that had the most resistance to it and had the hardest time trusting it. Our captains, pretty much off the bat, they were like, yeah, well, we can't beat a program like that that's looking at 5 years of data, data-driven, suggestions on move ups is going to be way better than the intuition that we have. So they bought in very quickly, and then the dispatchers, it took a couple months of getting them on board. There were a couple dispatchers that would, there were a couple move up suggestions that would recur and they wouldn't do them, and we'd go back and talk to them about it, and why are you not making that move up? And then we'd go back and look at the data, and I would just sit down with those dispatchers and say, well, let's come up with a hypothetical scenario of that same system and look at what the coverage gaps are and all those types of things. And once we go more in depth with the system and get down into the numbers and stuff, that's when the dispatchers would be like, okay, I get it. So.
Jamie, are you seeing that globally? That seems like that's kind of a theme. Reluctance to adopt that technology.
I think it's hard justifiably for dispatchers to adopt this type of technology. I think that they're all sometimes a little kind of over it when it comes to new tech that gets rolled out in the dispatch center. Rolling out a new CAD system and upgrading CAD systems, a lot of the public safety technology that they have to use every day is kind of old. It doesn't look cool. It's not like their iPhones. And so I think that there's this technology hurdle with having to learn something new and having to adopt something new. And then it's also doing different move up recommendations than they would normally do themselves. And so this is where having software that does look and feel new, that does seem like it's easy to understand, that they don't need weeks and months of training on, that they can look at a coverage map and click on a button and get what's happening, I think makes it easy. In fact, I love that from what you're saying, it sounds like they immediately were able to judge Live Mom based on the recommendations. They're not getting stuck on, this button doesn't work, I can't log in here. I think a lot of dispatchers have a rough history with having to adopt software that didn't work that well. And so they're kind of appropriately jaded when you try to tell them, no, this new great thing will be super easy, I promise. And, I can understand why it takes a little bit of time to trust it and to be happy with the recommendations. But even just having software that's very usable, software that's very pretty to look at, software that doesn't need a bunch of clicks, I mean, that's a whole different world than what they normally deal with on other stuff. So it's better that they're able to right away look at a recommendation and be able to use that as a platform of feedback instead of, I don't want to use any software for any of this stuff ever. But I think it also changes based on the length of time that your dispatcher has been with the organization. At least in my experience, I feel like newer folks are all about it. They're just like, I don't have to think about this. You have a software that does that. I'm in. But sometimes the folks who have been there for a long time, who have a very defined way of doing their job, their brain's kind of on autopilot with those things. It's actually more effort for them to look at the software rather than just doing it in their own heads. And so for them, the trade-off is different than the new dispatcher who's just like, absolutely, I'll click this button. You're very welcome. So different experiences there.
Well, I bet with the recruitment and retention issues in the 911 centers, like, always joke, my kids, I'm an old guy, my kids are grown up, but, I remember when they were like learning how to drive, I would say, look, put your head up, get your head out of the phone and see where we're going. Because, that younger generation today, mostly they get around on GPS, so they don't have that spatial awareness that us old dogs do, on where, how the city's laid out, this is kind of the geography and, it's no fault of their own. I mean, like I said, that's just the technology they grew up with. So they might not have that spatial reference that us more experienced people may have, just because we got around, based on some sort of sixth sense or something. I don't know how we do it back. I don't know how we did it back then. Now that I've got the technology today, but it certainly seems like a big tool for recruitment and retention. With as far as the younger generation, giving them tools. The thing that I think of, I remember being when I was the ops chief, when we would get busy and it would be on me to make the moves, right? So I'm driving code 3 down the road in the rain, trying to pay attention to where I'm going, sirens blowing, and I've got to think about what to move where, and not to mention the fire I'm going to. I didn't have the bandwidth for that, right? What I mean? It's like, I don't know, man, put them somewhere. It was kind of like, we're trying to deal with this problem. I'm not, and, if we were busy, the other battalions were also busy. So it wasn't like we had somebody sitting around with nothing to do. So my point there is what size organization, what size agency would this start to play? Like, should you be 10 stations, 100 stations? Like, where is that sweet spot?
I would say anything less than even 5 to 7 is you're probably just okay doing it on your own, but it depends. You could have some complexities and still maybe want to do like a partial version of it where you're just using it for like a coverage map. So you just kind of have an idea of where there are coverage issues. But yeah, there's only so many options in a small station area about who to move. But as soon as you've got 8, 9, 10 and above station count, it's very hard for the human brain to monitor all of that, to be keeping track of where everybody is and what move up should happen based on, what time of day it is. Is there any sporting event happening today? What's the weather like? How's the traffic been? What is the likelihood that something's going to happen at Main Street at 4:00 today? And execute that move up immediately. Whereas we know from the software standpoint that the technology is able to think about those things very quickly and make those situations happen. When you're a very small agency, you're probably able to stay on top of things. But yeah, the more that you're getting into that 8, 9, 10 station count and above, it's really hard to do the mental math on it. You're just better off letting some technology do the thinking for you.
How big can it get? Like,
I don't think we've found a limit.
Go the other way?
Yeah, I mean, we've done implementations with FDNY, with Queensland and Brisbane, and those are hundreds and hundreds of stations and pieces of equipment involved in those types of scenarios. So that's the other good thing about technology is that it scales. We do a lot of hosted applications and things like that too, to make sure that the performance and bandwidth of the application scales to that level appropriately. But I don't think that there's an agency big enough to be too big.
Okay. So I mentioned the 2-letter thing a minute ago, but I've been tinkering with this. Is this sucker AI or not? What do you guys think?
I think that AI is so ill-defined. It's really hard to say what is AI and what is not. I mean, technically, AI can be the chatbots that you get when you're trying to get help on a website. Like, that's technically AI, and so is all of the large language models and things like that. We're using operations research science, which is a key foundational part of all of the artificial intelligence that has now entered into the world. I think that we are like AI adjacent, maybe. I don't know. I don't feel like it's the same as the real AI.
What do you think, Jason? How do you see it?
Oh, I mean, the technology that feels smarter than myself feels like AI, and the live mom software feels way smarter than me. So I feel like it's AI. I mean, like you said, anything that's crunching data and understanding things on hundreds and hundreds of layers of information that we can't process in our conscious brains is something that is, like the live mom software, that's exactly what it's doing. So I call it AI, but I don't know what that term really, is. I'm not an expert on that stuff. So from a gut feeling, it feels like AI.
The definition does change
in a great way. It's like helping us meet our goals within our system to serve our community.
Yeah.
So.
I feel like maybe the definition is somewhere, I guess, between predictive and prescriptive, right? Like, so
there you go.
Predictive is saying something's going to happen that I maybe couldn't anticipate. Mm-hmm. AI, I don't know, getting there. Mm-hmm. But when you cross the line into here's what you should do about it, that to me feels like a decision was theoretically made or presented anyway, right?
Yes.
That's when I would be like, okay, now I feel like maybe we're getting there, as far as that goes. But it's been interesting to sit in these different industry conferences, meetings, all the things. And, the definition has certainly been a moving target as far as what is that and how to use it and those types of things.
Live mom technology is more intelligent than me. And it's artificial.
Jamie, what's your best use case story? Like, what have you seen it do that you went, oh dang, I didn't see that coming?
I think my favorite is very much with the Queensland ambulance service deployment that we did. It was the first large scale ambulance one, and we had the most resistance in some of these areas. It's a big state. And so this was like a central decision that not everybody else agreed with. And so there was a lot of resistance and a lot of ignoring the recommendations despite basically like mandates to do stuff. And we had a dispatcher send a report back that they had ignored one of the recommendations to move from a very busy area to a less busy area because they were concerned that it would diminish their coverage too much where that ambulance was at, and they didn't want to do it. And they declined the move up, and 7 minutes later, they had an incident out in that area that the unit had a very long response time to now. But if they had approved the move up as soon as it was recommended and wheels had started rolling, somebody would have been there 7 minutes faster than what they ended up getting there as. And for them, that was it. They committed everything else from then on in. They were just totally on board with it. So, but I love it when people doubt the software, watch it do something and become believers. I feel like it's okay for software to have to earn your trust, and it should. And watching it be able to do that is pretty cool.
And I should mention, when we say Queensland up in the States, we don't necessarily appreciate how big that is.
It's big.
It's
a big
like
chunk
almost,
of the continent.
Yeah. It's massive.
Yeah.
Well, very good. Well, I appreciate y'all taking the time to out of your day to come chat about this. I think this is where we're going to spend a lot of time over the next, decade or so in the fire service as we, as we start to, I don't think we're getting any more resources. Probably not. Nobody's budget's going to just blow up where you have everything you want. We can't drive any faster. The only thing we could do is be smarter. I think, like Prescott's on the right path as far as, if you really want to make a dent in these kinds of things, you have to be smart and use data and technology to get it done. That's I'm always harping on the FSRI search and rescue data that came back that 15 seconds makes all the difference. If I can put a firefighter on the porch 15 seconds faster, then it was worth the effort. So any closing thoughts there, Cap?
No, this is amazing. It's great to be here and listen to Jamie and you, Eddie, talk about things from your area of expertise. It's awesome.
Awesome. Thank you. And my best to Chief Dura. You guys have really set a nice example of how to get this done. It's really will be a textbook implementation, I think.
Thank you.
Jamie, any thoughts?
Just, I thought it was so cool to hear about how you guys did this and what you did. And I think just a couple of really key takeaways for anybody else who's looking at doing this. You cannot underscore enough the importance of doing the campaigning that you did with the other captains. The boots on the ground, face to face, not an email, not a release, not software training, just one captain to another reference point of this is why, this is what it's going to do, and get you on board. I would say that in other agencies, if they can find a you from the dispatcher side too, that's also amazing. And dispatchers can sometimes trust in and believe other dispatchers who are telling them this is the way you got to do it. But whatever it looks like, having somebody sit down and explain from the department about why you're doing this and why it's going to be important. I don't know. I mean, you definitely, I'm sure you guys had some resistance and some things were harder to overcome, but you overcame them. And
Yes.
A lot of departments let it die right then and there.
Yeah.
So I think that's very key. It was very cool that you guys did that. That's
awesome.
Implementation is definitely the key. Probably the most overlooked as well. Yep. Well, thank you all very much. That's a wrap for this edition of the Fire Service Data and Tech Talk podcast on fire engineering. We're available on all the social media outlets through that network. You can find us on Facebook as well. We have a Facebook page, Fire Service Data and Tech Talk Facebook page. We're on X with the handle is Data Tech Talk. And of course, you can always just find me directly on LinkedIn. If you have ideas for a show, you have guests you'd like to see, certainly let us know. We'll be happy to have them on. So that's a wrap for this month. Hope everybody has a good fall. Looking forward to things cooling off a little bit. Stay safe.
Fire Service Data and Tech Talk.